Chapter 12, Section 1, page 2. We will talk about the domain of a vector-valued function. Let's look at exercise 2. For the domain of this vector-valued function, we will find the intersection of the domains of each of the component functions. The domain of x of t is t not equal to 0. The domain of y of t is found by solving the following inequality. We get t less than or equal to 4. Just a side note here, if the radicand, the stuff under the radical, is a polynomial of degree 2 or higher, you don't solve an inequality by isolating the variable. You need to do graphing. And z of t is this function. The argument of the natural log function must be greater than 0. So we get t greater than -5. The domain of the vector-valued function r of t is the intersection, the overlap of each of these component function domains. And we see that we have the following overlap. This is where we see all three colors. So the domain of r of t is -5 less than t less than 0 union 0 less than t less than equal to 4. Let's look at note 3 about the parametrization of a line segment. First of all, you have to know the orientation, and if P1 is given by these coordinates and P2 by these coordinates, and you want an orientation of that line segment from P1 to P2, it's done in the following way. We need the restricted domain 0 less than or equal to t less than or equal to 1 to parameterize the line segment and the line segment only. Notice that if t is 0, we get x1i plus y1j, which would be the vector in standard position whose terminal point is P1. And if t equals 1, we get x2i plus y2j, the vector in standard position whose terminal point is P2. If you write the following parametrization, as you see here in orange, and you do not restrict the domain, what you have given is a parametrization of the entire line that passes through P1 and P2 and oriented from P1 to P2. So in other words, with no domain restriction, you are implying that t is any real number. So a common mistake I see is when giving a parametrization of a line segment, sometimes this is omitted. If that is omitted, then the parametrization is of the entire line. Let's look at exercise 3. We will give the parametrization of the line segment connecting P1 and P2 oriented from P1 to P2. 1 plus 4 minus 1 t all times I plus 3 plus 0 minus 3 t all times j plus 5 plus -1 minus 5 t all times k. Simplifying, we get the following. And the restricted domain to indicate line segment.